and good afternoon, everyone, and thanks very much for having me in this webinar. Appreciate that you spent about 50 minutes in my office with me today. Since you say it's Zoom, okay. So what you see there is I'm an architect in the office of the CTO in VMware, and the group is called Distributed Edge. And one of the main things we do, and if not the main thing, is we're building a grid. And the name this construct has at the moment, because grid is too short, obviously, is multi-cloud services grid. And what I want to do today is show you a bit on what the grid wants to be, what it is when we finish with it, and what it does. And by looking at these three different aspects, we're going to look at how we're building it. So it's not necessarily this is a technology we're using talk. This is more this is the rationale for choosing the right technology at the end to build a talk. And as you can see, the title already is a bit ambiguous, because you could read it as a multi-cloud grid of services, or a grid of multi-cloud services, or a service grid of multiple clouds. Or if you remove the dash, you could even have a multi-grid of cloud services. So any kind of combination is possible. That already hints that the grid can be and wants to be a few different things. So let's look at this one first. If we can advance the slide, there we can. So the grid essentially is a utility that delivers anything, anywhere. Anything that is digital to anywhere we can get connected. So any digital artifact that we have produced and that we can store and communicate or send over a network, this is what the grid actually wants to do. Part of these artifacts are distributed applications that we can deploy and run. So applications that run on multiple different nodes, at least two, or that run on one node and still use networking. That's the core area the grid wants to address. And it is a utility, so not necessarily the platform everyone has to use, but more in the terms of what we know from classic utilities like water, electricity, supply chains, kind of important these days. So you probably, if you get it right, you will notice the grid only when it disappears or when it malfunctions, like electricity. When electricity is out, that's the moment we notice there is grid, or when water is out. Ideally, that's what the grid will be. We want to build this, and we're going to build this with autonomous nodes, because when we want to deliver anything, anywhere, then of course the consequences that we're talking about a global scale. Which doesn't mean that everything in the grid has to be global. We can give nodes and domains, administrative or otherwise, autonomy, and let them decide within their sphere what they want to do. You can have these mechanisms hierarchical or otherwise organized, so we don't need a global universal grid as one single application, but more like multiple things. And then what we want to have running in and across these nodes are autonomic processes, so processes that can decide themselves what they want to do and how they want to do it, and using the grid as a utility to do so. And then there's four words that are usually scary, at least when we talk about them in my area, and that's the grid is distributed, it's recursive, it's parallel, and it's circular. Distributed because we're talking about networking, about things that run on multiple different nodes or hosts. It's recursive because we can use the same or similar mechanisms on many different layers of abstractions, or in different scopes, or in different domains. We don't want to build specific infrastructure and specific technologies just because we're changing scope. Everything in the grid is parallel, so there's no just sequential action with guaranteed transactions or asset properties. Everything can and will happen in parallel. That creates a few problems. And we're not building a single application like some companies do, like for instance, Netflix is basically a Netflix application, or Twitter is a Twitter application. What we will have is any kind of application running in parallel of any other kind of application. And then on top of that, the processes will be circular. You can start thinking about them in terms of closed control loops, and that gets you to circular interactions of the system. So there is science required for that. That's why we're talking to people like you in Connect, because you're scientists and researchers. We have a good bit there that we can use, but there's still a few circuits to square for this. And then you might want to ask some questions. For instance, is it a grid or is it the grid? Is it my grid or your grid or our grid, or is it their grid? Is it one grid or many grids? And the answer to all of those things is yes. When I say the grid, then it's because my team, our team only builds one. We're not building many, but it also can be a grid because it's a construct that we talk about. My, your, our, and there is probably something about ownership, or where you can join a grid or cannot join a grid. All of these things can happen at the same time. Is there one or many? There might be many. They don't have to be joined all together. And even if they're joined together, there might be many local grids. So all of the above is true. And when we say in this is obviously a task that is way too big for a team. It's definitely too big for Sven. It's way too big for the team I'm working in. It's probably too big for the office of the CTO of VMware, and probably also too big for VMware itself. So what we did is we created an organization called the Open Grid Alliance, opengridalliance.org. So you can find us there, and we have created the organization. We have announced it in April, and we have legally created it in October. The first meeting was in November. We have 30 plus companies. Do we have this here? Yes, we can actually go here if this works. There's the link, Open Grid Alliance, so we can just go through. And my network is busy with a webinar, so can't show you the founding members. Should have loaded the website before. There we go. There is founding members with big guys like AWS and Intel and Deutsche Telekom is in there, and then there's smaller companies like SMEs. But you can, back to the slides, find us in the Open Grid Alliance, which is not an open source organization. We have Linux Foundation and Apache and things for that. It's not an STO because there are many there. It's more a place where people can come in and innovate and build this out and find some grid locations that we will provide and play with their technology. That's the OGA. Okay, so my team is going to build something inside VMware. And there's going to be some VMware products coming out of this, but most of the work we do, and we're going to contribute to the Open Grid Alliance, and then make this happening with the partners that you just saw. Okay, so how do we see the grid? We start with multi-cloud operations, and what this does, should do, is that you get a single set of infrastructure, or if you want to think APIs, or if you want to think about event source or event-driven communication, then that, whichever way you want to talk to the system, that you can deploy your applications or use storage and memory and networking across any cloud provider. That's the public ones like AWS or Azure or Google Cloud or Alibaba, or apologies if I forgot your cloud, there's many of those. It might be a private cloud. It might be Cloud One and public-private partnership. It might be government cloud. It doesn't matter. VMware has products in the area. Other people have products in the area. So what we want to do is to have a single a view of compute, storage, memory, and networking as a single pool of resources, where we can go in and actually acquire some, and we know the conditions under which we get them, including payment if that's part of it, and time. And that we can then release those things. So you would think about in the multi-cloud, you would have definitely OpenStack, you have Kubernetes, the product in VMware is Tanzu, you have other things there, like Red Hat has very good products in this area, or IBM. You could use, yes, Donna, you could use Service Mesh on top of that to do that. That would be one way of building this, but it's not, we don't want to have pushing just one certain technology direction. What we want to look at is first, what capabilities the grid should have. Multi-cloud is one of those. Once we have this, we do in the next step. And my slides just froze. There we come back again. Is that for A, the applications that we're running, and B, our multi-cloud grid environment itself, that we want to build in time-sensitive communications or time-sensitive services. You might know from 4G, specifically then 5G, that there's a lot of discussion about ultra reliable low latency mobile broadband, and both of them in the enhanced version. Then later on in 5G evolution, maybe 6G, we have jitter and packet delay variation and these things. That's usually coming up when the talk comes about time sensitive. But time sensitive is a property of the application using the grid, not the grid itself providing a service. So if I need sub-millisecond round trip time or delay because we have moving objects like cars, then that would be the time scale and access for time sensitivity. But if I have, on the other hand, a scenario is you go to your GP, to your doctor, they have to download your patient file, that's a gigabyte. Obviously, this has to be downloaded within the time you have with your doctor, the half hour, ideally only the first couple of minutes of that. Then the time sensitivity is 2 minutes for download of a gigabit file. That's what the time sensitivity of the application is. And what we want to do here is have not pre-configured networks, but actually acquiring the resources on demand of the application, putting them together, stitching everything together, have it running, do the assurance at one time. And then once the application is finished, we can give all these resources back to the pool. Okay, so that's the time sensitivity. Of course, this full thing needs to be ultra reliable for whatever time scale we're using. But time scale doesn't have to be super fast. That's the only difference to what people talk about in 5G. Once we have this, we have the basic infrastructure for compute, memory, storage, and networking. And then we can start thinking about data. We can start thinking about intelligence. We can start thinking about data processing and mechanisms for data processing. This is what we call kind of the intelligence grid, and that is twofold. The one is a look at data processing. For instance, we can decide on, do we bring the data to the process? Do we bring the process to the data? Is there some kind of middle way to do this? Would we like to have event forwarding discriminators, like some data makes it to the process, but not all data, where the process can decide which data actually makes it through certain filter mechanisms? That would be kind of a data-driven environment. And the other side is that we would like to have standard mechanisms to work with data. You can think about this if you wanted to. Marketing would say it's AI or ML as a service, if you want. But there's a lot of standard view on data, especially in the networking side and in the cloud side, that we can actually generalize and provide the required algorithms. We can also provide box containers then, where you can put in your own model so that you have your DNN or your CNN running. So this is what we want to do in the intelligence grid. So at this stage, we have multi-cloud with time-sensitive, reliable services, and we can process data, and we get a lot of services for that for free from the grid. On top of that, we can now build autonomic capabilities, usually described as self-management based on self-learning and history, or self-healing, or self-operation. There's lots of different names for that. But it would use the intelligence available, its own decision-making process, usually built in a closed control loop with learning, and then manage the grid itself and manage the applications we're running in the grid. We've done this for about 20 years in telecoms and IT networks, and it gets momentum again because it seems to be a good time now to put this in the industry. And then on top of that, we would have your or my or their or our autonomous distributed application, whatever the grid is, but if whoever wants to use the grid, whoever wants to use the utility that we're actually providing there. So that's the way we're doing this. We started last year, early last year, 2021, with the multi-cloud grid, and we have a vision. I will have a link to this if you haven't seen Kanis Mahdi's talk on this, for 2030. So we're pretty much in the second year now of a 10-year journey, and we have multi-cloud there, we have time sensitive there in the lab. We're going to build this out to more outside lab conditions. We are looking into intelligence and autonomic grid at the moment, and we started building out locations in Montreal, a view in the US, at least one here in Ireland in Cork, where VMware has a 5G lab. And then we're talking with you guys in Connect about, how could we connect things there as well. So that's what the grid is. And then if you look in terms of 5G, because we're partially also responsible for the telecom business of VMware, then massive broadband, cloud native is very helpful for us when we talk to Deutsche Telekom, Vodafone, AT&T, Dish. Pervasive connectivity, this is one that you only get from a mobile network, actually. The other networks are not globally pervasive connectivity. They're also hard to deploy, so that's a pretty good thing. Openness and programmability comes on the O1 side. The core network might be the next one. Autonomic networks becomes an interesting proposition there, on time-sensitive communications just at the starting point if you look at ITOT and 3GPP discussions. So there's a lot of stuff actually happening in the industry and probably also in research that we need on our journey towards 2030. So the next thing I wanted to do is to use a real-world service or application where the grid could be useful. And I'm using rescue services, because I presented this to a conference about rescue services and first responders, but B, because this is actually a really interesting one. So we look into urban and rural areas. We're not just looking in, a big market of, Atlanta or New York or Las Vegas. We're also looking into rural areas. They have very specific problems on the rural side that we can actually do. Area of challenging landscape and topology, which is interesting when you have when you look into coverage, but also when you look into connectivity that is available, connectivity that might become available, and how to use that in different situations. Rescue services require good local knowledge, timely communication, because they're rescue operations, so someone is in trouble and they're going to go out and rescue that person. And they need timely information that is accurate. There's no point in telling a rescue people that something is important an hour after the fact, timely, or have the information, getting the information wrong. So there's a lot of requirements, not necessarily functional, but for services that the grid has to do. That's why rescue services is an interesting one. And this one I think you can relate to. Definitely the guys from Waterford can relate to this. So there's Dungarvan in the middle. That's where I live. That's why I use Dungarvan. And we have the guards and we have ambulance and fire brigade here. Then you have civil defense that would come in. You have an air ambulance in Mallow, and there's Coast Guard Rescue 117 in Waterford. Then we have a cliff rescue in Tremont, and you have the mountain rescue in the Commerce. You have the lifeboat from the RNI, and we have the Irish Coast Guard. So there's a multitude of different first responder and rescue services, and I don't have for first responders in the ESB and the water guys. There would be first responders as well in certain situations. And if the grid is a utility that delivers anything anywhere, it should be actually able to allow all these rescue services to communicate for their rescue efforts, or for their training efforts, or for their preparation efforts, whatever they want to do. That would be a situation where the grid should be ideally positioned. That's how we want to build the grid. And then there's two different scenarios that you have in rescue situations and in the grid. The one is happening with warning, some time to prepare for an event. In non-rescue environments, you would have frequent or regular situations, like you have the daily commute, which has different traffic patterns, morning and evening commute compared to lunchtime or midnight. You have seasonal fluctuations for holidays like Christmas or Easter or whatever comes in. You have events like sport events like GAA, national hurling, or the All Irish, or the Six Nations rugby. So these things, they come with warning or with time to prepare regularly, frequently, and we can put them into our plan of action. And then life just happens. So things happen without warning, anytime, any place, and they might have different severeness and different scope in which they run. Give you one example, you might have been here December 7 and 8 when the storm Barrett ran through. Sorry, Barrow did one through, and the Woolk south, west, and south. Actually, Waterford went red on this day as well. So here we get 4, 3, 2 days warning with the changing conditions. All first responders, all rescue services, and the grid, if you would have it, could prepare for this and could actually put everything in action. And then you have the things that happen spontaneously ad hoc in life. This is a rescue operation of Rescue 117 in Ardmore in September 2020. We just happened to be there on the beach, so I took those pictures. There was a swimmer getting into difficulties. He was rescued by local people, and then you have a local fire service there, you had ambulance, you had the guards securing the beach, and then they called 117 in to transfer that person to Waterford Hospital, made a full recovery as far as I understand. But these are the 2 different scenarios that we want to build the grid for. And if I put this then back to those rescue services that we just talked about, the larger number that we see here, then you would have compute and storage on many different places. There is a national network for these organizations run by the government that you could use. You can use local access, like any retailer in town or food outlet with free Wi-Fi. You could actually come in. You could use things like Virgin Media has 10% reserved on any Wi-Fi hotspot, so these services could actually use available Wi-Fi. We have currently dark fiber to wind farms that you could lighten up. Some people thinking about this so that you actually have fiber into the mountains where the wind farms are. You can build mobile networks around this. The rescue services could bring their own command and control centers. We're talking Northern Ireland, different European country, with police department to actually equip cars with cloud capacity and communication. You have to get the form factor right. They want this really, really tiny, but you would have those things in a police car used for all sorts of police activity. You can have this equally in a mountain rescue car as a command and control center to coordinate your search parties, for instance, in the Comoros. So all these isolated things, what we have to do then is building the grid. We actually have to enable them to talk to each other for their purpose within their domain using the technologies available, probably with multi-hub connections if there's different technologies in the place, and allow a distributed application, in this case, rescue someone, to use anything that's available there. So we're not building this particular scenario. I would really like to actually do that to see if it's possible to help the rescue services here in this country with a grid. I'm using this to explain it because I think it's a really, really interesting way of looking at this. Okay, and so the multi-cloud, just to come back to what I said, service grid, the multi-cloud services grid is a utility, not necessarily a platform or product that delivers anything anywhere, anything digital to anywhere we get connected. So we're on the edge of the cyber physical world. Maybe one day we can actually cross the edge. We could order a piece of hardware, get software pre-configured, have it shipped to a certain place and installed, and then connect it from there to the grid. Dell has those services, HP has them, and Vapor has them as well. We're using concepts like autonomy and autonomic processes, and we're using, from science and research, distribution, recursive, parallel, and circular mechanisms for that. You can check out the Open Grid Alliance. We wrote a blog, that's April last year. So it's not the newest one, but it gives you a good idea. And then there's the long-term version 2030 that Kanis Mahdi did present here to connect actually. So it's you guys who thankfully recorded her and put this on YouTube. So if you want to hear the long-term version, then that's what you can get there from Kanis. And with that, I reached the core talk that I wanted to get through. Just let me have a quick check for questions. So Donna is asking, if you want to build your own grid, what technology stack do you need? Kubernetes service mesh. Kubernetes would be good that you have your pods. Gives you interoperability because Kubernetes is becoming an industry standard for that. We would like to have this, that we can provide like a grid node that you can induce into your local service cloud, or however you want to build this. I have 4 Raspberry Pis down here that talk to each other. They're not using Kubernetes. They're using something very proprietary. I put a grid node in this and connect my Raspberry Pi cluster to the grid. So that's what I do. And then again, the heterogeneous part of one multi-cloud, multi-grid infrastructure data approaches seems to be a major challenge. Have you a vision to deal with this? Yes, we do. And if you give me another 10 minutes, Martin, I can actually talk you through this. I can show you a few things there, if you allow for this.
Oh, yeah, no, I mean, to say we have until the full hour. So,
okay. Yeah. And then Anonymous is asking, is this similar to Google Anthos? Similar, yes. The same, I'm not so sure, because I don't think Google goes for the same vision. But we'd like to have the Anthos actually part of what we want to do with the grid. We can learn from them, they can learn from us. So I'm not saying that we're going to go against Anthos. That would be not the way that we operate. So we don't want to do that. But I think Anthos in itself has a slightly different approach. Okay, so how do we do this? So you give me 10 minutes if I get my slides back. Okay, so what about the applications? And let's have a look at this. Do we have a concept of building this? We do. If you look into cybernetics, that's the science of control and communication. 1970s, 1980s, mostly driven by Heinz von Förster in Illinois. There's 2 different views on a system. One is the view of the organism, and the other one is the view of the observer. When I build a grid node, then I can obviously build it as the view of the organism, but when the grid node talks to whatever resources is down there, then the grid itself can only be an observer. So you have to be careful to distinguish between these 2 things. The application itself will always be an observer towards the grid node and the resources, whereas the grid node is the abstraction of heterogeneous resources towards the application. And if we take the view of the observer and follow that path for a moment, then you can have this application here, the darker green box. There's an interface gray on the left, an interface gray on the right, and assume an arrow coming from left to right, going into the left interface and then coming out of the right, so that you get a sequential workflow as you would do when you model functions and chain functions, monoid in functional programming. And observer A would see that particular application. Observer B might actually be able to look inside, might see the outside one, but would see the inside one. So get more information, more details about how processing works inside. Then you have an observer 1, who again can look inside the lighter green one and has these, what is it, sand-colored things there. And then you have an observer 2 who might be able to look into one of those, but there might be more detail hidden to that. So that's the way that different parts of the grid and the applications using it, because we're building the grid like an application using it, recursiveness, can look at the whole infrastructure on different scopes. Each view has a different scope. Someone looking at all these, so observer 2 is seeing a very detailed scope on a domain with loads of different moving parts, whereas observer A is seeing a very large scope, but only one part inside, because obviously for observer A, nothing more is important. That's one way of building this. And then if you turn this around, change the perspective, because this is kind of 2D, it's hard to show. You could show it this way. So you have the application on the top, the big one, dark green, and then you have those lower ones. And if you change the perspective again, you can actually express this as a schema. Once we have the schema, we can identify invariants because we see similarities. So important is not that we have a top-level application with interfaces going, to smaller part of other applications. Important is that what we have here is these little gray circles. There are processes. They run in a certain layer or facility. Of these layers facilities, I can have multiple things, and then my processes here can talk in the vertical or in the horizontal. So each process then is actually doing a very similar thing to communicate, and maybe a very different thing to realize a particular application. So, but we can still go and find a lot of similarities. Facility, we can identify systems. This is where a node would be located. This is a hosted capability or a resource, like my Raspberry Pis down here. Each of them is a system, or the laptop in front of me from which I do this. Processes in isolation, we can combine these things together into pairs. So you have your facility and your process. You have process and system and facilities. And you can look in the overall communication. And one thing that we have here is that services and protocols are a side product of actually looking at a system like this. So we know what protocols in the system have to exist. Then we can go and select the actual technology we want to use. Obviously, on the lower side here, the closer we get to a wire or to a radio connection, the closer we get to, say, Ethernet or a 5G air interface, NR. On top of that, you might have something like WebSockets, or you might have something like Kafka as an event bus, or you might have a BSD socket. If you do low-level networking, that's fine too. The higher we come, the more high-level functions we would want to have, and the more these protocols would change towards what I would call conversation, where you can federate about or discuss semantics. And actually exchange understanding, because that's what you want to do on the application level on the very, very high top. Most things today run somewhere in the middle. That's where most applications would be today. Once we have these protocols here, we can also then look into how would I map a conversation to a Kafka event stream? How would I map this down to some communication facility used on the lower parts? What are the implications when we do time sensitive? That's kind of important to understand, also technical details. And then we also get the services, at least we know where they are. So these services here are actually an interface. How do you do your interface? You use an application protocol, or you use an API/SDK, or you use events that go over there. You can do that too. Do all these have to be the same? No, they don't. You can use different APIs and different mechanisms here actually for anything I want. And there's no harm if you can generate protocol and service from the overall system description to generate any kind of API. So you don't have to sit there and write the API. The important part is, how is the system described? How would you describe the resource information in the abstraction, not in the detail? The detail is a mapping problem. And then you can take that and put this, back into the grid using the isometrics. So it looks a bit like the other grid that we had there. And this is all I had prepared for today. I hope you enjoyed the journey. I hope you got a few pointers, hopefully some of them being interesting for you. We'd be definitely interested to have an open conversation. We'd be very interested in feedback. We're also happy if someone comes and challenges us and our ideas, because that helps us to build a better grid at the end. So thank you very much for your time today. I really appreciate this. Thank you.